Hey everybody, hope that you all are doing well. So in this video, I'm just going to go over the test review. So feel free to skip around to anything that you had questions about, and hopefully this will help. If you still have questions, please don't hesitate to hop on a Zoom session this week. I'm available during first period, during fifth period, and also on Wednesday during my office hours. So if you need help with any of this before you take the test, please hop on a Zoom session or shoot me an email. All right, so the first part, you were just labeling the different types of solids. So a few of these that I want to talk about. Number one, so first of all, number one is a prism because its sides are rectangles and it has those two parallel bases. So remember that with a prism, you have two bases and those are connected by rectangles. With a pyramid, you have one base and the sides are your triangles that are all meeting at the top. So in order to name a prism, we name a prism and a pyramid by the shape of its base. So this prism has a hexagon on its top and bottom, so that's why it's a hexagonal prism. Looking down at number 8, this is obviously a pyramid, which we also name by its base. And if you count the sides, it has 1, 2, 3, 4, 5, 6 sides. So its base is also a hexagon, which makes it a hexagonal pyramid. The other one that I want to talk about really quickly here is number 7. This is a shape that hopefully you've seen before. We didn't really talk about this a whole lot when we did polygons earlier this year. But this shape is a prism because it has two parallel bases connected by those rectangles. And in this prism, the base here is a trapezoid. So a trapezoid is a quadrilateral that has two sides that are parallel and the other two sides aren't. So that's a trapezoid. That's what makes this a trapezoidal prism. Hopefully the other ones here were pretty straightforward. The rectangular prism, cone, cylinder, sphere, and square pyramid. All right, so moving on now to the formula part of this. So for 9 through 14, this was literally just copying formulas that had already been written in your packet. Numbers 9 through 11, those are formulas for two-dimensional shapes. Those are formulas that we use in the midst of our volume and surface area formulas. So for example, the area of a triangle, we need that to find the surface area of a triangular prism. Area of a rectangle, we need for surface area of rectangular prisms. And area of a circle, we use that a lot. We use that for surface area and volume formulas. Number 12, actually, too, the circumference of a circle. That's another two-dimensional formula that we're actually using with these three-dimensional shapes. So then you have surface area of a cone and a sphere. So that was just copying straight from your packet. The ones that I really want to talk about here, number 15 and number 16. So make sure that you understand and remember the difference between slant height and height. So slant height, let me grab my pyramid here, sorry. Slant height, remember, is the height of the slanted side of your pyramid or your cone. And height is if we dropped kind of like a string from the vertex straight down to the bottom of the solid. That would be the height. So height is straight down, slant height is this one on the side. So to calculate surface area, that uses the slant height. That uses the height of that triangle on the side. To calculate the volume, that's where we use the height of a cone or a pyramid. And so then we have our formulas here for volume of a cone and a sphere. Those just came straight out of your packet again. All right, so the next group of problems was all surface area problems. So I actually already have the work written out here, and I'm just going to kind of talk through it and show you on the shape where these numbers are coming from. So to find the surface area of a rectangular prism, we're adding up the area of all of the rectangles that make up the prism. And remember that they come in pairs. So the left and right side are the same. The top and bottom are the same. and the front and back are the same. So that's why each of these area formulas is getting multiplied by 2. So the surface area is 2 times, and then the 4 times 6 there, that's the area of the bottom of this prism. So that's also the top. That's why that number gets multiplied by 2. The 6 times 9, so that's going to be the area of this right side over here, which is also the area of the left side. And then the 4 times 9, that's going to be the area of this front piece, which is also the area of the back piece. And so when you do all those calculations, you get 228 meters. And don't forget, for surface area, we're always going to square our unit, so meters squared. Number 20, so this is a square pyramid. So our surface area is going to be the area of the base. That's what the capital B is. So the area of the base is 6 times 6, 36. Plus, we have to add up the area of all of those sides. And that's what the 1/2 perimeter times slant height does. So the perimeter of this base, remember that's just the distance all the way around the base. So we have 6 plus 6 plus 6 plus 6. That's where the 24 comes from. And then the slant height is, this right here, which is given to us as 12.4. And then plugging all of that in gives us our surface area. Okay, so our next one here, number 21. So this one is a cylinder. Surface area of a cylinder is 2 times the area of the base. That gives us the 2 circles, the top and bottom. And then circumference times the height gives us the area of that rectangle that's wrapped around the side of the cylinder. So in this one, make sure that you are careful with the measurement that you're given. That 8 kilometers is the diameter. So that means that the radius would be 4. And then area of a circle is pi r squared. So that's where this pi 4 squared is coming from. Plus the circumference of a circle is 2 pi r. So that's the orange there. And then the height of the cylinder. So remember that with prisms and cylinders, the height is the distance between the bases. So if it's laying on its side like this one is, it's not necessarily the measurement that's going up and down. So here your height is actually the 7 kilometers because that's the distance between the 2 circles. And then putting all of that in your calculator gives you the surface area for the cylinder. Number 22, so this one is a cone. For a cone, we need the area of the base plus 1/2 the circumference times the slant height. So we were given the radius here. The radius is 3 centimeters. So the area of the base is pi 3 squared plus 1/2 the circumference is 2 pi r, so 2 pi 3. And the slant height here is the 7.6. That's that slanted edge of the cone or a pyramid if this was a pyramid. All right, number 23, so spheres. These are probably the easiest ones because you only have one number to plug in. Surface area of a sphere is 4 pi times the radius squared. And we were given the radius, so you literally just have to plug that into your formula. Number 24, so I think that triangular prisms are not the hardest, but they're the ones that you have to be most careful about figuring out your different areas. So for a triangular prism, your 2 triangles are going to be congruent. So your 2 bases. So in this one, here's our triangle base right here. And the area of a triangle, remember, is 1/2 base times height. So the base of this triangle is the 6 and the height is the 8. Because it's a right triangle, you could actually switch those and it wouldn't matter. So the area of that triangle is the 1/2 8 times 6 or the 24. And we multiply that by 2 because there's a matching triangle on the top of the prism. So we have to account for both of them. And then we need to find the area of the 3 rectangular sides. So the first rectangle. That's what the L1, L2, and L3 are. Those are your 3 rectangle areas. So 11 times 6 is this rectangle right here. 8 times 11 would be this rectangle on the left side. If the height of the prism is 11, then there would also be an 11 back here. So that's a kind of an easier way to see the 8 times 11. And then we also need that one that's on the back. And that one would have a measurement of 10 times 11. So 10 times 11 is that last area here. And so when you add all those up, that's where the 312 meters squared comes from. All right, so moving on to volume. So the volume of a rectangular prism or a box is the area of the base times the height of the prism. So the area of the base here is 10 times 8. That's the base of this prism. And the height is the 6. So 10 times 8 times 6 gives us the 480 meters cubed. It might help you to remember, this could be useful, especially like on SAT and stuff. The volume of a box is kind of the generic name for a rectangular prism. Volume of a box is always going to be length times width times height. A lot of you might remember that from middle school. And so you can think of it as area of the base times height, or you can also just think of it as length times width times height. But that only works for rectangular prisms. Number 26, so this is a triangular prism because we have our 2 triangles that are parallel. So the formula is the same, area of the base times the height of the prism, but because the base is a triangle this time, then we have to use that formula for finding the area of the base. So the base is the triangle right here. Its area is 1/2 times base times height. So here the 4 and the 3 are our base and our height. The 5 is the hypotenuse. So that gives us the area of the triangle. And then the height of the prism. So again, just like with the cylinder up in the surface area problems, the height of the prism is going to be the distance between the 2 bases. So the distance between the triangles. So in this one, that's what the 5 is. So it's not necessarily the measurement going up on the prism, but it's how far apart those 2 bases are, which is 5. And so that's what we plug in for the height of the prism. That gives us 30 centimeters cubed. Volume is always cubed. All right, number 27, we have a pyramid. So volume of a pyramid, 1/3 area of the base, and volume uses the height of the pyramid. So the inside height, not the slant height. So the area of the base here is 16, 4 squared. And the height, that inside height right here, is also 4. So 1/3 times 16 times 4 is 21.3. All right, so number 28 is a cone. Cones have the same volume formula as pyramids, 1/3 area of the base times the height. But for a cone, the base is always going to be a circle, so we use that formula for the area of the base. So in this one, we are given the diameter. If the diameter is 16, the radius would be 8. So the area of the base here is pi r squared, pi 8 squared, and the height of this cone is that height in the center there, the 16, which gives us the volume for this one. Number 29, this is a sphere. For a sphere, 4/3 pi r cubed, to make sure that you're cubing the radius when you're finding the volume of a sphere. We were given the radius in this one, so you just had to plug right in. Number 30, a cylinder. So area of the base times the height, exact same formula as for a prism to find the volume. So the base has a radius of 4. Area of the base is pi times r squared, so pi 4 squared. And the height here would be the distance between the 2 circular bases, which is the 9 yards. So that gives us our 452.4 yards cubed. All right, so the last set here, these are ones where you have to kind of apply the formulas and work backwards. So in 31, you were given the volume of a triangular prism, 96 feet cubed, and you were also given the area of the base and asked for the height. So this was a pretty straightforward one. So I plugged in the volume as 96 right here. I plugged in the area of the base as 12, and then you just had to divide by 12 to find the height of this prism. Number 32 requires a little bit more work, so I'm actually going to work through that one on the video. So this time we were given surface area of a sphere, and we're being asked to find the radius. So this is our surface area formula. Generally, we plug in the radius to find the surface area. This time we're going to plug in the surface area and work backwards to find the radius. So we were told that the surface area is 900 pi. It is important that you put the pi in because that's actually going to cancel and make this problem a whole lot easier. So because there's a pi on both sides of our equation, we can actually just divide it away and it's going to cancel out. So that means now that our equation is 900 equals 4r squared. Divide both sides by 4, and we get 225 equals r squared, and then we take the square root of both sides, and the square root of 225 is 15. So our radius would be 15 inches. All right, and then the last one, this was one, we did an example like this in your notes. Where we have to find the slant height. So the height and the radius and the slant height always make a right triangle. So you can always use the Pythagorean theorem to find the slant height if you're not given it. So the slant height here, I'm going to use that cursive L like the formulas use. So the slant height is the hypotenuse of that right triangle. So remember that Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. So c is actually going to be our slant height. So the a and the b are the 7 and the 3. They're the two sides of the right triangle. So 7 squared plus 3 squared equals the slant height squared. So this would be 49 plus 9 equals L squared. 49 plus 9 is 58. So the slant height of this cone is the square root of 58, which is about 7.6. So that's how you find the slant height from the height and the radius. You just use the Pythagorean theorem. All right, so hopefully this helped clear up any questions that you have. If you still need help with something, or if you still have questions about something on the review or anything from this unit, like I said at the beginning, please feel free to hop on a Zoom session this week or shoot me an email and we can schedule a time to chat before you take the test this week. Hope you guys are doing well. See you soon.